We're going to get underway. I mentioned that I saw some of you in Liz and Dimitri's session on Monday. And you may have recalled that on the sign outside it said that Dimitri was going to be one of the presenters here. And I am not Dimitri. I am Rick Golba. And I'm also joined by another one of our Percona consultants here named Stephane Combaudon. I had it.
Not bad.
Combaudon, yeah, sorry. I actually practiced that one. And we're going to go over some information on MySQL replication. So just to give you an idea of the topics that we're going to be discussing here, we're going to start out talking about what is, and probably of equal importance, what is not replication. And this is one of the areas that I know that we get a lot of questions. And as a matter of fact, I was on a call earlier today with a customer, and they said, we want to set up high availability. And I basically asked them to end up describing high availability in their world. And in their world, it was replication. And we'll talk about what it is and what it isn't in that situation. We'll go through some use cases as well, so that we can get some ideas of places where it is totally appropriate to look at replication as your solution. We'll go through the different types of replication that exist. You're probably aware that as MySQL has matured, they've added some new options in for replication. So when we're looking at some of these slides, you're going to see as of version this, prior to version that, and so forth. So we're kind of trying to cover all of the versions here. And that does, of course, mean then that in some cases, some of the information that we talk about here may not be in your system, depending on the version that you're dealing with. We're going to talk about a couple of other things that sometimes come into play here. One of them is the idea of replication lag. Now, as we're going to see, there's a possibility of intentionally setting up replication lag. And that one, you can do it, and there are reasons to do it. We will talk about what those are. But the real issue is when you have lag that is coming into your replication setup that you didn't expect. And we'll talk about some of the ways that you can go about diagnosing that and start pointing you to things that you might want to consider looking at so that you can start to resolve that. Then we'll talk about a couple of the replication errors, really looking at the idea of what happens when errors occur in the replication world. Because there are situations where replication will continue, and there are situations where replication will stop. And obviously, you want to know what has caused that. And then my colleague will do a demonstration of some of the replication. And again, with the fact that you all, those of you who were in Liz and Dimitri's presentation on Monday did not get to see that, I think that will be, again, a very valuable thing. As I mentioned, just going back here, my name is Rick, and I am a technical account manager with Percona. I joined the company last year, and prior to that, I'd worked for about 23 years as a corporate trainer, and most recently working with the Vertica database product, if any of you are familiar with that, and doing some other database products along the way. It's been a long and varied career. I'm actually going to pass the mic over to Stephane and let him do a brief introduction of himself as well.
Thank you, Rick. Hello, everybody. So, as Rick mentioned, my name is Stephane Combaudon. Correct pronunciation. I'm a consultant at Percona, which means that I'm doing the actual technical work. And basically, replication for me is everywhere. So it's very infrequent that I work with a customer who doesn't use replication. So if you don't know a lot about replication, really this talk is for you, because as you'll see, there are so many use cases for replication that, well, for almost every issue that you can have with replication, with MySQL, replication is probably something you should look at. And so, very briefly, I've been working with Percona for about 3 years, and before that I was a MySQL DBA for several large companies, and actually I decided to switch to regular MySQL DBA job to a consultant job, basically because, well, my thought was it's more exciting to see lots of environments. It's like in the morning, I work with customers in Australia, running MySQL 5.5, and in the afternoon, it's a customer in the US running Percona XtraDB cluster 5.6, and they all have different issues. Well, that's kind of fun. So that's why I'm here.
Thanks. And as you may have inferred, Stephane is from Dallas, Texas. No, he's obviously from France. Most of the Perconians, as you know, work from our homes, and I'm fortunate enough to work from my home, which is in Hawaii. So I've come to the cool weather here in California, but I'll make do. So as you will recall, the first item here is what is and what is not MySQL replication. So let's talk about replication, and this is kind of a standard definition of replication. It's the ability for us to copy data from one database server to another. And when we get into looking at replication, we're going to have the database that is the source of this information is the master, and then the database that is the target is the slave. And as you'll notice on the slide, it says you can have one or more slaves. Now, it's also possible to have intermediate masters and so forth, but we're really kind of going for the basic levels of information here. And I know when I talk to my clients, most of the cases where people are looking at replication, they're looking normally at having more than one slave. When we get out to the use cases, one of the reasons that people will often have multiple slaves is they'll have a slave that is servicing one area, another slave servicing another area, and so on. And the other thing that this allows us to do is to really use replication as a way of scaling our environment. Now, when you look at replication, it is either asynchronous or semi-synchronous. And this is the default behavior. And what this means is that the slaves don't always need to be connected to the master. And this can be nice if you have a situation where you have some bandwidth constrictions and you don't want to have that traffic going all the time. Of course, it does then mean, this is one of those cases where you have that idea of built-in lag. You know that your slave may not be absolutely up to date because it may not have connected to the master in the last hour, the last half day, whatever it might be. Now, of course, there is the idea of synchronous replication out there, but that is a factor of the Galera cluster. So that's a different option than what we're looking at talking about in this situation. And then one of the really nice things about replication, and again, this will come up in the use cases, is that it's not necessary that you replicate everything. You can choose to replicate all of your databases from the master to a slave. You can choose to limit it to specific databases or to specific tables. And if you keep that in mind when we start going through some of the use cases, you'll start to see how that makes sense in a lot of these different situations. So, as important as what replication is, we need to talk about what replication is not. And the first bullet here says it. It is not a full high availability solution. Now, can you use replication to mimic high availability? Yeah. If you have a master and a slave, your master fails, direct all the traffic over to the slave. But bearing in mind that we're talking about something that is an asynchronous process, we may not actually have all of the information on that slave. Now again, when I talk to customers, in some situations, they're totally okay with that. I had a customer that I was talking to yesterday, and they said, you know, if we lose some transactions, it's okay. It's a cheap product that we're selling. It's okay if we don't have all the records there. But we still actually stay up and running, and we give our customers access to their information. In other situations, we've had customers who said, there is no way that I could sustain the loss of a transaction. And in that situation, then you need to start looking at the Galera cluster and looking at full high availability. The other thing you don't have with replication is an automated failover process. If you have a situation where you have a master and a slave, and there's a failure of the master, you actually have to redirect the traffic to the slave. It's not something that automatically happens. So these are just some things to bear in mind. Now, as I said, we're going to see that there is a possibility of kind of mimicking some of the high availability in this. But you have to ask yourself that question, how critical, how crucial is it that your slaves are absolutely positively up to date, if that is what you're doing? And that is why I know when I'm on calls with customers, I'm sure Stephane does this when he is dealing with customers as well, we get into what does that mean to you? And it's kind of interesting because these words of replication and high availability and all those things, we all throw them around as if we all know what they mean. But realistically, they all do have slightly different definitions. So we're going to kind of come up with very standard and very basic definitions of these terms and concepts today. So let's talk a few use cases here. I've already mentioned the first one, which is the idea of using it for scale out. Now, when you have replication, what you're doing is you're directing your write traffic to the master, and then you can direct all of the read traffic off to the slave or slaves. And this can be a really nice way of allowing your system to scale without actually needing to add more masters into the environment. You have the master sitting over here. It's taking care of all of the write traffic. And then you have the slaves that are able to handle all of the different read requests that are coming in. And this is quite nice because obviously it will improve your write performance. You have one machine that is handling all of the write requests. And it will improve your read performance because now you have machines that are really pretty much dedicated to just doing the query requests and processing those through. And as your system grows, and you get more and more requests for more and more read requests coming through, you can add additional slaves into the environment. So you can just keep scaling this through. Now, another comment I will make about what we're seeing here, we're kind of talking about each one of these use cases in isolation, but obviously they can be kind of combined out in some situations. So as we work through this, you'll see some situations where you might look at it and go, well, if I did this, and then I just had read activity, that would be even more efficient. And you're definitely on the right track if you're looking at that sort of a situation. Another way, another reason you might choose to use replication is to enable some data security in your environment. And this is really looking at using one of the slaves for backup. And if we've ever been on a call with you, one of the questions that we've probably asked you is, what are you doing for backup? And realistically, when I ask that question, I hear two answers very frequently. The first one usually starts with some hesitation and ends with them saying, nothing. And then the second one is, well, we use a slave for that. And in that situation, you would replicate the data to the slave, you'd stop replication, and then you would back up the data from that slave so that you're really keeping it very isolated. And you're having your backup process really running in a very safe and secure manner. So this is another really nice use for replication. And again, you know, once again, looking at combining these things out. This is the idea of having one slave for backup, other slaves that are just processing regular read requests, and so on. Yeah, it says high availability. I know I said it's not a high availability solution, but it can be used to mimic high availability. And in this situation, you're taking a little bit of the control into this. And this does mean that it's possible that you'll have to do some work at 3 in the morning. But if that's a good enough solution for you, then it's a good enough solution. And there's no shame in that. That's a very good thing. If you need fully automated high availability, hey, we can do that. But it's kind of like anything that's out there right now. If you look at the manual, actually, I was in the car last night with Dimitri, and Dimitri being from Belgium, of course, he's used to a manual transmission. And me being an American, I'm totally used to an automatic transmission. And it's kind of the same thing. And I remember when it actually cost more money to get an automatic transmission in a car. You bought manual transmission cars, one of the things was they were cheaper. And it's kind of the same deal here. If you do the replication for your high availability, one of the reasons might be cost-based. The other one, again, might be the fact that, yeah, if we lose a little bit of data, if we have a little bit of downtime, it's not that big a deal. But we can save ourselves some hassle by implementing replication for this. Now, another thing is, as the amount of data that we're processing is growing, and as the types of queries that we're looking at are growing, looking at analytics is a big area here. And with analytic queries, in a lot of cases, you're dealing with massive volumes of data, and in some cases, some pretty intense activities that you're taking on analyzing that data. So by having a slave or a couple slaves that are really dedicated to running those analytic queries, that can be another really nice way of, again, separating that information, those requests out. You might have an area in your company where you have a bunch of quants who are working who just say, you know, this is what we do. We run analytic queries all day long. And so you can set up a slave or slaves that they access. And that actually kind of gets us into the idea of data distribution as well. And this is another one of the use cases for replication. You can use replication as a way of bringing data closer to the consumer of the data. So in my example there, if you have these folks who are running the heavy analytic queries and they're all based out of your office in Palo Alto, you can have a slave that's in Palo Alto. Your master can be somewhere else. You could then have another slave that is in New York or Boston or Chicago or something like that. And you have different people who are accessing that data. On top of that, bear in mind, you don't always have to replicate all of the data. So the folks on the East Coast might be seeing a completely different data set than the folks on the West Coast are. The folks in the analytics team might be seeing even different data. So it's a nice way of feeding people data close to them and just the data that they need. And of course, the less data that you have on your system, the better, because your queries are going to be more efficient. They're going to be able to run more quickly. And as Stephane said, there's a lot of use cases here. We've gone through a few. These are the really common ones. And like I said, think about the idea of combining these out as well. But there are lots and lots of reasons why you might look to implement replication in a MySQL environment. Now we're going to talk about some of the flavors of replication. And the first thing we're going to talk about is GTID replication, using global transaction IDs in order to manage your replication process. And as you can see here, this is one of those areas where we're going to give that little version disclaimer, because this came into the product as of version 5.6.5. And at that point, there was the implementation of the global transaction ID. And what this means is that each one of your transactions is uniquely identified in a global situation. Prior to this, you might have a transaction that took place on the master, and then when that transaction gets replicated to the slave, it would have an entirely different ID. From the master to the slave, different IDs. And if you have problems, if you have errors that come up, that can make the process of doing troubleshooting much more complex. Now, using global transaction IDs, we have the ability to really easily path that all through. Replication becomes a transactional process, so it's actually more efficient in that situation. And what we're doing when we're using the global transaction ID is that when we have a transaction that processes through, as you can see here, we're going to wait until the transaction has been, we're going to wait to commit the transaction on the master until it has been actually applied on the slave as well. And we're making sure that this has actually worked out. This is actually getting us into one of the other varieties of replication that we're going to see in a few slides from here. Again, new as of 5.6.5. It does require that you use global transaction IDs, and there are some considerations around that. But this is a nice option if you particularly have to get into any sort of troubleshooting with replication. What I'm going to call classic replication, the standard replication, the vinyl album of replication, if you will, is the idea of using the binary log. And I'm sure you all are familiar with the binary log. It's being used to record every single action that happens on that server. Well, now, when you have replication running, you have a master server, and you have one or more of these slave servers. Each one of them will have their own binary log. And with the idea of using the binary log here, what we're going to do is we're going to record the events on the master in the master's binary log. And then when the slave contacts the master, it will copy down the binary log information. And then it will start replicating those events on the slave. But now it's writing those transactions to the binary log file on the slave with, I wouldn't even say probably different IDs. I'm going to probably go so far as to say absolutely they're going to have different IDs on the slave. You can actually, when you're doing binary log replication, you can tell the system where to start and where to stop the replication. And this is actually how, when you're just ongoing through replication, this is how it knows where to pick up. It knows where it stopped in the binary log on the master before, so it just picks up from there. This is classic replication. It still works well. I actually, moments ago, kind of jokingly referred to it being like the vinyl album of replication. And again, I'm old enough to remember vinyl albums. I'm old enough to remember 8-tracks. And it's funny to me to see that vinyl albums are making a comeback. And we've kind of got the same thing here. One of the reasons is it's very clean. It's very direct. And we've got a very similar analogy going on here with binary log replication. And I mentioned that replication is asynchronous or semi-synchronous. And this is another one where you can see we've got that disclaimer. As of version 5.7, you can now have semi-synchronous replication. And we'll talk about what that is. But by default, replication is designed to be an asynchronous activity. And again, this can be really great if you don't have a need for either very timely data. You might have a case where people, if their data's an hour old, it's not that big a deal. So you might just pull the data on an hourly basis instead of having it happen more regularly. And if you're dealing with any sort of situation where you have constrictions on your bandwidth or something like that, you can really use this to control that. But as of 5.7, you can also set up the idea of the semi-synchronous replication. And I'm going to call your attention to that semi in that one because this is not fully synchronous replication. It's coming darn close, but it's not fully there. And you can see the process that we're going to go through here. We're going to have a transaction that takes place on the master. On the master, that transaction will not be able to commit until at least one of the slaves has acknowledged that it too can commit the transaction. And so if you have multiple slaves, this can allow you to get into a situation where this one is semi-synchronous and this one is asynchronous. So this can be a really nice way, again, of keeping things a little closer and tighter in that up-to-date situation. Particularly when you're looking at high availability, that can be a really good thing. But I keep putting this disclaimer in. This is not a full high availability process that we're looking at here. So 2 different replication formats that we have. The, again, classic, if you will, is statement-based replication. And in this case, you can imagine this from the bin log, because in the bin log, we have all of the statements that were processed on the master. We copy that bin log over to the slave, and we just do those transactions again. So we are actually processing each and every statement. And you can see that this was the default before MySQL 5.7. But from 5.7.7 forward, we have the ability to look at row-based replication. And this can be a much more efficient option because in this situation, we're only replicating data that has changed. So if we have a situation where we have run some request that didn't actually alter the data in any way, we don't need to do that on the slave. So it minimizes the amount of activity that we need to do on each one of these slaves. That can also lead to the slaves being kept more current because the slave doesn't have as much work that it needs to do. Replication lag. It's possible, like I said, to have your slave be intentionally some time interval behind the master. If you set that up, great. You're going to have some replication lag, but it is built in and it is by design. The more vexing problem is when you have replication lag that is coming into your environment and you didn't expect it, and in some cases, you didn't notice it. And sometimes when you don't notice it, you don't notice it until it's too late. One of the reasons that this can be a little bit more difficult also to deal with from a troubleshooting perspective is the inconsistency. You might find situations where there is lag, and then it goes away. It resolves itself, and then it comes back. And again, another analogy here, it's like when you take your car into the mechanic and you say, there's a rattle in my dash. And of course, you go out for a ride with the mechanic, and there's no rattle in your dash. And the mechanic says, I don't know what I need to fix. And it can be kind of the same thing, because you might start looking at this and going, hey, there was replication lag there. And then, someone comes into your office, your phone rings, you get an IM, whatever it might be. You go and you do something, you come back and you're like, it's gone. And it can be a little bit difficult to figure out what caused it in that situation. But there are a few things that you can consider looking at in here. There are several different reasons that you might have lag that comes into your environment. First of all, on the slave, your transactions are being serialized. So we're really kind of gated by what sort of activities the slave can handle. So you might end up just building up a queue because you're trying to fit a lot of data through a tiny little slave. And it says, you know what? You guys need to stand in line. We'll clear out the line. And then that's the other issue, is at some point you stand in line, there's replication lag, and then when it says, you know what, I can handle this, there's no lag. And you're looking at it going, what the heck? Sometimes it's there, sometimes it's not. So you're going to want to start looking at what the cause of this lag is. We'll be talking more about that. Certainly, hardware issues can cause replication lag. And you can certainly see how that could happen. If you have any sort of hardware issues, either on the side of the master or the slave, this can start causing lag to build up in your environment. Another one here is configuration changes. I'm sure no one in this room has ever made a configuration change on their master and not made the change on their slave. That has never happened in the history of MySQL. Another one is a MySQL restart needing to happen, and we need to reinitialize the buffer pool. So we've got that slave, or potentially the master, doing some other work, and it says, you know what? Everyone else got to wait. So you get a little bit of lag in that situation. And then, of course, the other two would be increased activity on the slave or increased activity on the master. If you have a lot more read activity on the slave, now your slave is getting a little overburdened. And it says, I'm going to honor those read requests, and that replication stuff, yeah, I'll get to it. I'll get to it when I can. It's basically looking and saying which one of these situations is bleeding. And the one that's bleeding is the requests coming in from the user saying, I need this information. It says, I'll give you the information, but I got some information sitting over here that I haven't been able to process just yet. And the last one is increased replication load. If you have a lot more activity coming in on your master, you're feeding more data down to your slaves, and that can cause a problem. So to diagnose lag, there are two things that you kind of want to start by looking at. And this is because replication actually functions under two different threads. There's the I/O thread, and this is the one that is going to connect to the server and actually copy down the bin log and get everything ready to work through. And as you can see here, we're copying that down to the slave, and we're setting that up in the slave's relay log. And then the other thread is the SQL thread. And this is the one that's actually going through, looking at that relay log now, and going through and executing all of those activities. If you can pinpoint your lag to one of these two threads, it can start to help you to hone in on what the problem is. Given that the I/O thread is about contacting that master and getting the information down, if you're seeing your lag there, chances are that it's network-based. You either don't have enough bandwidth, you've got too much transactions, you've got something there that you're trying to squeeze more data through the pipe than the pipe can handle. So we've got the data kind of stretching out, and we get our lag coming in there. On the other hand, if it's SQL thread that's causing you the problem, then it's very likely that the issue is based in the queries themselves, the requests, because it's taking too long to resolve those queries on the slave. It took that long on the master, but it didn't commit on the master if we had that sort of activity happening. So if you can figure out which one of those threads is causing the problem, that can be a huge help to you. And the last thing here is the idea of replication errors. And this is really talking about what happens to the replication threads if and when you encounter an error. And in the first situation here, you see that we have the same error on the master and the slave. Basically, both of them agree that this is not a valid request. If that's the case, we go, yep, okay. We can actually log that error, but we move on. We just keep going. It was a bad request. There's no reason for us to worry about that. The bigger issue is when you have either the master and when you have the master and the slave with different errors. In that situation, we had the same request. The same request should not give us different errors on two different servers. So in that situation, once again, it's logged, but now your replication thread will shut down because it says there's something going on here that's not quite right. And that's when you guys need to come in and figure out what the cause of that is, and you need to go in and resolve that issue. So this is really about the idea of how do we resolve the potential issues that come up. I have talked far long enough, and I'm going to hand the mic over to Stephane, and he is going to do a demo for you. Thank you, sir.
Thank you, Eric. So what I suggest is that we start with questions if you have, while I'm figuring out how to connect my computer to the projector. Shouldn't be a big deal, but, well, who knows? So maybe any question right now? Yes.
When we say we need to pinpoint the lag to rather IO thread or SQL thread, how do we determine that? Usually when we run show slave status or something like that, it's usually just one number for the slave.
Right, very good question. So actually, it's quite easy to know. So what you have is basically two kind of issues. So when you have issues with the IO thread, as Rick mentioned, it can be network-based, a network-based issue, or it can be an issue with the grant. So like to set up replication, you need a dedicated account. So you need the slave to be able to connect to the master. And if you didn't set up the right properly, well, that doesn't work. That's an IO thread error. But if everything is correct there, then the problem is with the SQL thread. And when you see show slave status indicating 10 seconds of 10 for seconds behind master, it means that the SQL thread is lagging, right? So actually, when you have replication lag, it's most likely the SQL thread. So I'd say more accurately that when you have an issue with the IO thread, what you should see is probably, if I remember correctly, second behind master is null. But I'm not sure actually, because it doesn't happen very often, so I'm not sure if it's null or zero. So it may be wrongly indicating that, oh, well, no problem. So, thank you. Yep, over, oh, yeah.
We've seen, we're from the same company.
Ah, okay.
Cases where the IO throughput is, for whatever reason, the master's running really busy and not able to process getting the data to the slaves, which is also a case. And the way you determine that is by in the show slave status, it will tell you which master log file, relay log file, and you can compare the master log file that's currently being written with the one from the master.
Mm-hmm.
And if there's a significant gap between them, then that's a case of an IO thread having a problem.
Yeah, exactly. So this is something that can happen, for instance, when you have an issue with your slave and replication stops for 1 hour, 2 hours, for at least a long time. And then when you reconnect the slave, or when you restart replication, the slave has to fetch data from the bin log of the master, but data that is old. And old data is no longer in the cache of the master, of the bin log cache of the master. So in general, when replication is working correctly, the bin logs are in memory on the master. So there's no I/O load. But if data need to be fetched from the disks on the master, well, that's some I/O load. And if you have not a single replica, but let's say 10 replicas that are very far behind, and then when you reconnect them, well, that can be a lot of I/O. So, well, if that's something that can happen for sure. Yeah.
Also, something I've seen in the past is a symptom of I/O being bottleneck is the seconds behind master will actually fluctuate between how many seconds it truly is behind to 0, because it has no statements waiting to be replicated on the slave. So that the slave says, okay, I'm caught up, and then it reads the next event and says, oh no, I'm an hour and a half behind.
Yeah, right. So that's back to your question. So when the I/O thread is a bottleneck, actually you don't. So when you have an error with the I/O thread, I think you should see seconds behind master is null. But when the I/O thread is slow, what you will see is that the seconds behind master is fluctuating. So when the I/O thread is a bottleneck, well, you see that the SQL thread is in sync. So it appears that it appears like you have no replication lag. And then when the I/O thread gets a bunch of bin logs, well, suddenly you have 10 minutes of replication lag. And then again, it's 0, 10 minutes. So that's like that. Any other question right now? Yeah.
So what's the really meaning for the second behind? It's sort of like it's not a real second, and they change, depending on the log and the.
So yeah, that's a very good question. So seconds behind master is one way to measure how far behind a replica is compared to the master. It's not always accurate, but it's some sort of a good indication. So like if you see seconds behind master is 10, so it's in 10 seconds, well, that means that you have replication lag. However, if you see seconds behind master equals 0, that does not exactly mean that you have no replication lag. Because actually the thing is that the granularity for seconds behind master is 1 second. So when you see 0, it could be like 0.05 seconds, which is not a lot. But if you have a high concurrency environment, that could be, well, I don't know, 1,000 queries, so the slave can still be 1,000 queries behind or transactions behind the master, which can be a lot, right? Anything else? No? Okay. So what I suggest here is to start with the basics. So I have 3 windows here. The first one will be a window for the master. Then we'll have a slave, and we'll have an app server. It's basically to demonstrate how you can, in a very naive way, how you can split your read load, right, between a master and a slave. So at the moment, I have one master, and I don't actually have one master and one slave. I have 2 independent servers, and I'd like to show you how to set up replication. So this is here the easiest case, which is I'm starting from scratch. So I have no data, right? If you have data, it's just a bit more complex, because what you need is a backup from the master to initialize the slave. Yes, question?
Do app servers talk to the master directly or talk to the slave?
We'll see that later. So at the moment, forget that one. Well. So you have 2 servers, 2 MySQL servers here, and what we want to do is to make sure that whenever we write here, the data will get there. Okay. So on the master, we have a few requirements. So the first requirement is that we have binary logging enabled, because replication works with binary logging, as Rick mentioned. So you write on the master. The transactions are written in the bin logs, and then the bin logs will be copied over the network to the slave. So the first thing is that we have to go to the configuration file, and we should make sure that we should make sure that no, it's not the good one. Oh, yeah, it's the good one. Yeah, it's the right one. We should make sure that the log bin setting is enabled. And we also have to make sure that the server ID setting is correctly set. So basically, the server ID is an identifier of any server in a replication topology. So for instance here, I chose the number 102. It can be, well, anything. So I'm saving, restarting, because when you enable or disable binary logging, you should restart the server. Restart. So yeah, what you'll see here, I didn't mention that, is I'm doing something interesting. So on this side, I have MySQL 5.6, right? And on this side, I have a slightly different server, which is Percona XtraDB cluster 5.6. And the thing is, when you use replication, it's not mandatory that you have exactly the same versions on the master and on the slave. The main thing is that you make sure that the version of the slave is at least the same. It can be higher. So here, for instance, I will be replicating from, well, let's say Percona server, so a modified version of MySQL, to MySQL. And that's going to work because they're both 5.6. Okay. So on the slave, the only thing we should add or make sure that that it is set up correctly is the server ID. And the server ID should be unique for every server. So here it's 103. Okay, so here I need to restore the server. Okay, so the next thing to do is to create on the master a dedicated user for replication. Okay, so what we have now is binary logging is enabled, so anytime we write to the master, this will be recorded in the bin logs. Great. Now we need that the slave is able to connect to the master to fetch the bin logs. So on the master, we will create a new user. So grant, we only need one privilege, which is replication slave on all databases. And I will not choose a name that is too fancy. So the replication user will be named Ripple user, Ripple_user. And we can set a password identified by PWD. Like that. So a good thing to do at this point is to go to the slave and make sure that using this new account, you can connect to the master. Because if you can't, well, you'll never be able to start replication. So let's try MySQL -u Ripple_user -p -h and the master. So the IP of the master, I know it by heart because it's my VMs 234.102. Password. The password is PWD. And it works. Cool. Okay. So we have the bin logs enabled on the master. We have an account to connect from the slave to the master. Now what we need to do is to instruct the slave that we will replicate from the master, which should be a given MySQL instance. And we will specify which user we will use, and we'll also specify from which in the bin log stream we will start replication. So for that, we will go to the slave and run a change master command. Okay, so the beginning of the, I'm not sure if everyone sees that. Yeah. So the beginning of the change master statement is very easy. We say, okay, let's connect to this host using this user, this password, and now we have to find the position in the bin logs where we need to start replication. So how can we find that? Well, to find that, we have to go to the master. And on the master, we will run show master status. Okay. And we see, well, the master is at, is executing, is currently writing on bin log number 5, position 323. So we should use that information for start slave. Yeah, just 1 second. Yes, question.
So every time you run the show master status, the return gonna be different. Does it matter?
Sorry, could you say that again?
Every time you run show master status on the master server, it's gonna give you the different return. Does this matter?
Oh, yeah, so that's a very good point. So here my server is idle. So if I do that different times, well, I'll always have the same position. On a running master, you cannot do that, right? Because here, as I mentioned, this is a simple case. You have fresh servers and you have no traffic. If you have a real server, so you have a real master which serves traffic, you cannot do that. What you have to do is to take a backup from the master. And from this backup, oh, we're almost done. Okay, thank you. From this backup, you must record, so you must record at the time of the backup the binlog position. And you will use this binlog position. I will show you very quickly. So, change master is okay. Now let's run start slave. Start slave. Okay. And to make sure that everything is working okay, we will run show slave status. And the main thing is to see if both slave IO running and slave SQL running are equal to yes. And here we can see that we have an issue with the IO thread, which is not good. So what's wrong? It says that, well, the replication thread is not able to read the bin log. So I've probably, yeah, it's binlog 4 and it's binlog 5 and I said binlog 4. So I probably had an issue with my copy paste. So let's try again. And this time, after entering correct information, it's working. And you can see, well, so it's working. So how can we prove that it's working? So here we have only the default databases. On the master, I'm going to create a new database, demo, and it's there. Okay? So we're running out of time, so very quickly. So I'm going to create a table in the demo database, insert a few rows, and then show you how to connect with your application either to the slave or the master. Okay, so I have a table T with 3 records inside, and here I have my very small application. So it's a PHP application that does almost nothing. What it does is, oops, PHP. Oh, there's something wrong. Okay. What it does is basically it executes select count star from the table T, and it says where has it been executed. So 103 is the master. 103 is the slave, sorry, and 102 is the master. So here, for some reason, I've modified things while Rick was speaking, which was probably a bad idea. Yeah, I don't know. So well, I don't really have time. So let's. Yeah, I know. I should specify here that one. Okay, so that's better. So here I'm telling to my application that I want to use the master, and it says, well, okay, I have 3 records fetched from the master. And if I say, oh, let's now run the same query from the slave, well, it says, okay, I'm querying from the slave, and well, cool, I have 3 records. So basically, the code is simply, and I'll stop here. The code is basically here. So I can tell, well, let's connect to the master, 102, or to the slave. So in my application, I can say, okay, this is a select. So, and I don't care about replication lag, so let's connect to the slave. Okay, so let's offload the read load to the slave, because I know that the master is busy, so anytime I can run queries on the slave, it's better. And in another part of the script, we could have an insert query. Oh, well, this time an insert query, it must be executed on the master. So this time I would have connected with, to this server, right? Okay, so this is how you can, a very simple way to split reads and writes. So each time you have a select, well, run it on the slave. Each time you have a write, well, run it on the master, okay? Maybe 1 or 2 very quick questions, if you have. Yes, no, no. Well then, thank you very much.